day, ladies and gentlemen. Today we are looking at solving quadratic equations. We've got two different ways we're going to show you to solve them today. One of those ways is using this null factor law. Second way is going to be using the quadratic formula. Let's go. So firstly, null factor law basically says if I've got two numbers, they're multiplied together and I know that equals 0, I know then that either the A is 0, the first term, first part here is 0, or the B is 0, or both are equal to 0. So that's a possibility because anything multiplied by 0 is 0. So if I know I've multiplied two things together and I get 0, that means one or both of them must be 0. So if I get a quadratic equation, I've got to try and solve it. I've got to try and find what x equals. Okay, that's what solving is in this context. We're trying to find what x equals. So if I want to do that, I'm given some kind of formula. I need to get it into the form ax squared plus bx plus c equals 0, and then factorize this side here so that I get it into the form of something times something else equals 0. Okay, if I get it, you know, say x times y, no, that's a bad example. That's a bad example, not x times y. Maybe like m times n equals 0. I got it as two things times 0. Then I can say, well, hey, that means that m equals 0 or n equals 0. That's a possibility too. And then I can simplify if m or n are in terms of x, I can simplify them and find out what x is going to actually equal. And I can solve it. So rely on some prior knowledge here. We need to remember how to factorize those quadratics. So we're gonna do some examples now. Let's do that. So firstly, let's look at A here. We got a simple one. It's x squared minus 15 equals 0. Already in that ax squared plus bx plus c equals 0 format. And this one, if we look at what's on the left-hand side, if I'm looking to factorize this, I can see there's a difference there. I got an x squared. I can do a difference of perfect squares. So that means this is in the format of x squared minus square root of 15 squared equals 0. Difference of perfect squares. I go the first thing plus the second thing. That's squared, the square root of both of those things, and then the first thing minus the second thing. There we go. Yeah, equals 0 there. Okay, so I've done this as a difference of perfect squares. That means either x plus root 15 equals 0 or x minus root 15 equals 0. Because if this thing could be 0, and that'd make the whole thing 0. Or this thing could be 0 and make this thing 0. So we can say that either of those things might be true. So that means I get here x equals negative root 15, or x equals positive root 15, if I have a look at those. So that means we can say x equals plus or minus root 15. I've actually just thought of a much easier way to solve this. So let's go back and have a look at that. This is a legitimate solution, mind you. This is a legitimate solution. So let's have a look at another way of solving this one, of solving A. I got x squared minus 15 equals 0. Hey, I could make this just x squared equals 15. That's pretty easy, right? So then if I take the square root of both sides, I get x equals square root of 15. Now, where's the catch here? I don't get the minus root 15, but I know if I have a negative of root 15 and I square that, so negative times a negative makes it a positive. So therefore, anytime I take the square root of both sides, I've got to add the plus or minus, because it could be a negative. It could be a negative. Two negatives multiplied together, they make a positive. So it could be true. Obviously, a much simpler way to solve this one that I hadn't thought about. But let's have a look and use that simple way to solve this next one. I've got 2x squared equals 50. Divide both sides by 2 and I get x squared equals 25. Take the square root of both sides and I get x equals plus or minus, mind you, square root of 25. Oh, I can do that. That's plus or minus 5. because then I can substitute it back in and double check if I want. I can go negative 5 squared, that's 25 times 2 is 50, that's fine. Okay, let's move on. I'm wasting too much time here. Let's have a look. X squared minus 5x plus 6 equals 0. Okay, we've got a quadratic here. We've got to solve it. Ax squared minus bx plus c. Got it in that format. To solve this, we need to factorize. We need to factorize by grouping. So we go AC, that equals 6. B equals negative 5. That means my pair of factors, negative 2, negative 3, they will add to give negative 5, and they will multiply to give 6. So then I express my negative 5x as those two factors. I go, oh, I don't need to write the equal sign there. Forget about that. I go x squared minus 2x minus 3x plus 6 equals 0, because I've already got the equal sign here. I don't need to double up on that. Factorize this bad boy, and I get x for the first two terms. I'm going to factorize the first two terms. Remember how to do this. Factorize those first two terms. Highest common factor of those is x. Take that outside and I get left with x minus 2. And then of the next two terms, highest common factor of these two here are negative 3. Negative 3, and I'm left with x minus 2, because negative 3 times negative 2, positive 6 there. Positive 6. Factorized by grouping, I've got x minus 2 there. Take that out the front, x minus 2, left with x minus 3. That equals 0. Now, null factor law, that means that x minus 2 equals 0, or x minus 3 equals 0. Solve both of these little equations here, get x equals 2, or x equals 3. That's my answer. That's my answer there. X equals 2, x equals 3. And see what happens if I input either of these in here. So I put x equals 2 in, I get 2 minus 2, 0. And I get 2 minus 3, that's negative 1. But it doesn't matter, because my first term there, I multiplied by 0. So, I mean, I get 0. And you can see I get the same thing if I substitute it in 3. If I substitute in 2 to the original equation, back up here, I'm going to try and substitute 2 in there. I get, let me see if I can do this in my head. 2 squared minus 5 times 2 plus 6. So I get 2 squared is 4 minus 10 plus 6. So I get 4 minus 10, which is negative 6. Negative 6 plus 6, that equals 0. So that totally works. Tick, tick. So I've done myself a little check there to make sure that everything's A-OK and hunky-dory, and it is. Let's have a look at D now. Okay, you can do these checks all the way through with any question. If you're unsure, you just substitute that value that you get back in, and you'll be able to tell whether or not it's correct or not, because you'll get the answer or you won't. So AC is 1 and B is 2. The two numbers that multiply to give 1 and add to give 2 are 1 and 1. That is super easy. So I get x squared plus x plus 1 equals 0. Common factor x, take that outside, x plus 1 left over, plus, oh, it's only 1 times x plus 1. There we go, 0 equals 0. So you can see where this has come from. Okay, you can see where this has come from. I factorised the first two. Remember, I factorised the first two and then factorised the second two. Highest common factor of both. Highest common factor for the first two was x. Highest common factor for the second two was 1. Crazy, crazy times. So here I've got x plus 1, x plus 1. There we go. Oh, look at that, it's x plus 1 squared. That's so cool. So that means, hey, this is an interesting solution that we get, because I've got here x plus 1 squared equals 0. That means, therefore, x plus 1 must equal 0. It must equal 0. So that means I get x is equal to negative 1. So there's only one solution to this quadratic. Only one solution. Only one answer that will work. No other answers work. Just a 1. Just x equals negative 1. There's only one solution to that. And that's possible with a quadratic. You might solve it. There are 3 possible answers you can get. You can get one that has 2 solutions, like in A, B, and C. You can get one with 1 solution, like in D. It is possible to get no real solutions. It is possible to get no real solutions. So you can either get 2 solutions, 1 solution, no real solutions. And we'll look at that in just a second. So here we go. 10. Last example. 10x squared minus 13x minus 3 equals 0. AC here is negative 30. B is negative 13. Negative 13. So two numbers here, negative 15 and 2. If I add negative 15 and 2 together, I get negative 13. And if I multiply those two bad boys together, I get negative 30. So here we go. Let's factorize this. 10x squared minus 15x plus 2x minus 3 equals 0. Factorize the first two. Highest common factor is 5x. I'm left with 2x minus 3. Highest common factor of the next two is 1. And I'm left with the 2x minus 3 equals 0. Take the 2x minus the 3 out the front, and I'm left with 5x plus the 1 equals 0. A little bit more complex this time. Use the null factor law. Using the null factor law, I get 2x minus 3 equals 0, or 5x plus 1 equals 0. Solve these. 2x minus 3, I get 2x equals 3. X equals 3 on 2. One solution. Second solution, I get 5x equals negative 1. X equals negative 1/5. There we go. And my two solutions for this one problem here. So let's recap this scenario here. Firstly, you've got to get it in the form of something equals 0. Ax squared plus bx plus c equals 0. Factorize whatever is on that side. Or if it's simple, you can try and just solve it, like in A here and B here, either of these two. That is quite simple to solve. Then if you factorize it, then use the null factor law, solve for each of those two factors for equaling 0, because either of those two factors or both of them could equal 0. Alright, another way to solve now, rather than using this null factor law, which is a really good way to do it, is called the quadratic formula. Now this sucker you're going to have to remember. Okay, you're going to have to memorize this. Okay, after many practices though, you will memorize it, because for each example you've got to write down the formula. Every time you practice a problem, write down the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You've got to remember it. You've got to remember it. Where this is derived from is basically, if you remember back to completing the square, if you take this general form here, you take this general form, ax squared plus bx plus c equals 0, and you complete the square on that general form. If you actually do the algorithm for completing the square on that form, it will spit this bad boy out right at the end. It's complex, it's hideous, it's annoying, but this is what you get if you just do the general form, complete the square on the general form. You get this quadratic formula here. So the part of the formula that's under the square root, this part here, b squared minus 4ac, it's called the discriminant, because it discriminates whether or not there is going to be two solutions, one solution, or no real solutions. We give that a little symbol here, delta, Greek letter capital D, capital delta, okay, is equal to b squared minus 4ac. If this discriminant is less than 0, the equation has no real solutions. And the reason for that is, if we've got it less than 0, that means it's a negative number. That means underneath the square root's a negative number, and we can't do that with real maths. It becomes an imaginary number, so we'd have to do away with that. When delta equals 0, the equation has one real solution, and when delta is greater than 0, when the discriminant is greater than 0, the equation has two real solutions. This is just interesting. This is just interesting kind of what we can do to check ourselves. You'd have a bit of practice at determining the number of solutions to a problem, but often what we really want to do is actually solve it. So let's do that. Let's do some practicing here and actually have a look at solving these using the quadratic formula. Now, luckily enough, each of the examples that we have here are already in the form of ax squared plus bx plus c equals 0. So, I mean, if it wasn't in that form, you're asked to solve that, you've got to get it in that form. You've got to get it in that form somehow. Okay, so you rearrange it until you get 0 on one side. Okay, so let's have a look at the first one here. Okay, always write the formula first. I'm telling you, always write the formula first. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we get here, and we can substitute into our formula now. B in this case for A, for part A here, B is 5, so we get negative 5 plus or minus the square root of 5 squared minus 4 times A, which is 1, times C, which is 3, over 2 times 1. Show that substitution. So I've got negative 5 plus or minus, simplifying underneath the square root, I've got 25 minus 12, which is root 13 over 2. As a precise answer, we can stop there. We can stop there and say that is the answer. It's negative 5 plus or minus root 13 over 2. It's simplified. It's a simplified surd. That's as simple as it gets. We can stop there. But what I would like you to do is give the approximate answer. You'll realize this in a couple of videos while we would do this. So we give a little squiggly lines to say, this is approximately, and we feed that into our calculator. We feed the negative 5 plus root 13 over 2 into our calculator. We do the negative 13 plus root 13 over 2, and we get negative 0.697. Then if we feed negative 5 minus root 13 over 2 into our calculator, we get a second answer, or it's approximately equal to negative 4.303. Now the reason why we will do this is because we will want to plot this on a graph later, and you can plot that. You can plot this and this very easily. You can see where those numbers are on a graph, but you cannot just immediately say, oh yes, that's exactly where that is on a graph, because it's in surd form. It's absurd. So you need to make sure you really, you do this approximation, please. Okay. So key points I want in your answer. I want this in your answer. I want to see the formula. I want to see you substitute into the formula. I want you to simplify it as much as possible, and then I want you to give approximate answers. Four things I want in your answer. Let's look at the last example, B. B is 2x squared minus 2x minus 1 equals 0. Write the formula. X equals negative b plus or minus the square root b squared minus 4ac over 2a. Substitute in negative of negative 2. That's going to be a positive, but just show that you're substituting it in. Square root of negative 2 squared minus 4 times 2 for A times negative 1 for C, all over 2 times 2. Simplify. 2 plus or minus the square root. This becomes square root 12 because we've got negative 2 squared, which is 4, and then plus 12. Sorry, 4 plus 8, which is 12. And then all over 4. Now this isn't simplified enough. I get 2 plus or minus, because I can simplify this surd. This surd becomes 2 root 3 over 4. I got a common factor here of 2. 2 on the top, 2 on the bottom. I can divide the top by 2 and the bottom by 2. And I get, underneath here, 1 plus or minus root 3 over 2. Okay? That is my simplified exact value, but I want you to provide the approximation as well. So the approximation here, you would write x is approximately equal to, and then put it in your calculator, put it in plus first, and get the answer for plus. Answer for plus, 1.366. Or answer for minus is negative 0.366. Okay, so recapping today, we've got 2 different ways we can solve these quadratic equations. First way is we can factorize on one side, use the null factor law, make each of them equal to 0, solve each of those ones to get any of the solutions that there might be. Second way is use this quadratic equation. We need to practice to make sure we can memorize it, and then substitute in and solve.